So the Halosport is an over-the-head external neuron stimulator. Basically, it looks like a pair of headphones with all these spikes that send electrical impulses to your motor cortex. If this is your brain, it's a good brain. These are all the groups. If this is your brain, this area right here is your motor cortex. Basically, that controls all your movements and mechanical functions. And the reason why the Halosport is able to improve your motor cortex and your mechanical abilities is it does something called hyperplasticity, which causes rapid dendrite branching. So we can actually compare the neuron to a metaphor that the cell body works as a battery pack, which powers the neuron as a whole. The dendrites are like the plugs in a cord that plug into other neighboring cells, so other presynaptic cells that transmit impulses. And those impulses are like electrical currents, and that is more than just a metaphor. That's actually what these impulses are. And basically, they travel down the axon, which is like the actual cord of the power cord. And then you get your axon terminal, which connects to the other neurons to communicate with them, and that acts like another plug, plugging into an extension cord. So the Halosport interacts with your neurons and your motor cortex by lowering the activation energy. Basically, all this means is a neuron needs a certain amount of input in order to fire. Everyone's heard the term neurons firing. And basically, all that means is that they're receiving enough electrical input to create a response and communicate with your body and your limbs. What the Halosport's doing is really simple but extremely cool. They're using neuroscience and external input to prime the neurons of the motor cortex. Basically, all this is an external input of electrical signals. Here's your headphones hovering over your motor cortex, and they're always adding just a little bit of electrical input. Basically, your neuron at resting is at negative 30 millivolts. That's how much electrical energy. It's slightly negative. If a little bit of energy is put into the neuron right here, you reach this activation point. Basically, this shocks the neuron out of resting. It fires, reaches a positive charge of positive 70 millivolts, and after the neuron fires, this is where it fires. Here, I'll draw a lightning bolt. This is where it fires. It then depolarizes again to reach about negative 30. It actually slightly overshoots, and then it returns into resting. The Halosport is basically keeping the neuron, instead of at negative 30 at its resting point, it keeps it a little bit higher, so a little bit more positive. Basically, that means you need a little bit less input in order for the neuron to fire. And why this is important, you can just speed this up or something. And why this is important is because every time a neuron fires, it basically gets practice. And your brain is actually plastic, which means that it can constantly change. So as your neurons are getting more and more work, my drawing won't be good as Catherine's, but that's okay. You'll get the gist. But this is the cell body with the nucleus, and these are the dendrites. Here's your axon and your axon terminal. The more practice your cells get, the more dendrite branching occurs. You can't grow new neuron cells entirely, but you can undergo dendrite branching. And basically, the more that these dendrites branch, the better they can communicate with other cells, other neurons that is, to create faster, more efficient, and accurate information and communication. So basically, the Halosport is lowering the activation energy by priming electrically your neurons and your motor cortex, creating hyperplasticity, which means more rapid development of your dendrite forests, and basically it's thickening the cable of your power cord so that more information can be more quickly and accurately passed through. What we're seeing is the Halosport the Halosport company, that is, did an overview study and found that college athletes that were using the Halosport experienced much greater increase in leg strength than patients using placebo products and control groups. Basically, over a 2-week period, college athletes using the Halo Sport saw a 12% increase in leg strength, while people not using it saw only a 1.7% increase on the same diet and regimen. So the Halo Sport is not a miracle product. It does still require a lot of training in order for it to be effective, just because it needs a lot of input in the motor cortex and a lot of practice. Here's the little hand holding weight. A lot of practice so that your neural plasticity can be activated, causing the dendrite branching and therefore the increase in efficiency in your motor cortex. So therefore, people who are using the Halo Sport who aren't training will see an absolute 0% increase in ability. So yeah, that's about it. That's an overview of the Halo Sport and the neuroscience behind it.